Awesome. I'm excited to talk about some DPUs today.
I think we're live, Ron.
Are we live?
That's what it says.
All right, we are live. I kind of missed that part. Maybe that's the schedule for the show. Hey, thanks everybody for joining. We are going to be talking about the rise of the data processing unit, or DPU. We got some really great people here who really know what they're talking about. We have Baron Fung from Del Oro, Scott Schweitzer from Acronix, and Patrick from Serve the Home. So I think it's best to let people introduce themselves. So Patrick, can you tell us a little bit about yourself?
Sure. I'm Patrick Kennedy. I founded Serve the Home back in 2009. We're almost 15 years old, which is insane at this point. We've become the largest server storage and networking review site in the world. And more recently, we have launched a YouTube channel, which just passed about 500,000 YouTube subscribers. We've been talking about DPUs for many years. So I'm really excited to be here today.
Thanks, Patrick. Baron. Oh my gosh, we just lost Baron. Scott, can we ask you to step in?
Sure, I'll jump in. I'm Scott Schweitzer. I'm with Acronix. I've got a 20-year history in high-performance network adapters. I came over from the high-performance computing space where I was with IBM and NEC. Joined Miracom, helped them transition to 10 gig Ethernet for a lot of things, but more importantly, financial trading. Helped them set the world record for tick to trade back in 2017 at about 98 nanoseconds, and then moved over to SolarFlare, where we reset it back down to 26 nanoseconds, and now I'm with Acronix, and we're really pushing FPGAs and how to create performance pipelines for high-performance networking.
Okay, thank you very much. And a little bit about me. I am not just sitting here to be a well-spoken moderator. I've been in the network industry for a long time myself. DPUs, smart NICs, network flow processors, a lot of the flagship companies that are present today. I've spent some time at, and really love the whole NIC space. I love chips, and like being able to talk a little bit about where we're going to be going and why we've gotten here today. So once we get Baron back, I'll introduce him. But if we could move into a little bit of a primer on DPUs, we got a really good audience, and we see folks that know this space and have been in this space and have driven this space, and folks who are very new and might not know why we're where we are. So Alex, if I could ask you to pull up my first slide. So it's been an ongoing evolution, and we've talked for years about revolution versus evolution. And, NIC started out with just getting packets and punting them up to the host. Now, obviously, there's the other direction, which is taking packets from the host and sending them out. But when you look at a NIC, what did it do? And that's, the 1 gig, 10 gig space back in the dark ages. Moving forward, hey, let me pause right there. Baron, we lost you for a second, and we've done our introduction. So I'd like you to give a chance to tell us a little bit about yourself.
Yeah, I apologize for the interruption. So hello, everyone. My name is Baron Fung. I'm an industry analyst with Del Oro Group. Del Oro Group is a market research firm based in the Silicon Valley, where we cover the markets of telecommunications, enterprise networking, and data centers. So my responsible coverage lies in the data center infrastructure, specifically with server storage and server connectivity, including DPUs, as well as accelerated computing. So nice to be on board.
Thanks, Baron. Thanks for coming back in too. Appreciate it. I know technology it is what it is. Speaking of networking, Alex, can you move forward, please? So as this industry networking cards has moved forward, we've added simple offloads. Back in the day where TCP was offloaded for tow engines, then we moved into VXLAN. Very simple offloads today, but at the time, we called those smart NICs because they were better than no offloads. Moving into the 10 gig, 25 gig space, roughly speaking. Obviously, this is a kind of a broad brush. And then we would move forward a little bit. And we get into what we'd call more of an advanced smart NIC phase. Again, as the network technologies evolved, originally they would hit the CPU, and then we started offloading them onto the cards. So offloading things like vSwitch and NVMe functionality, crypto capabilities. Instead of just having a look-aside device, we'd have an inline device. So this is the era of looking at 25 gig moving to maybe 100 gig, early stages. And then we got into DPUs. And essentially, this evolutionary process has taken us to adding processor cores to a high-speed NIC data path. And what that does is it allows things like, a full server element to run on a NIC card or DPU. This is mainly in the 100 gig, 400 gig space. You can see on that, the processor is much bigger. There's memory added to the card. Potentially things like a BMC is added to the card as well. So that's basically how we've migrated throughout the years. And we can look at the different kind of types that are out there. Like the early DPUs were a dedicated NIC chip with another, like an FPGA or CPU cores added to it, connected via PCIe or something like that. Today's more mainline model are two things, like a system on chip, which is the NIC pipeline with and processors all embedded into a single ASIC, or an FPGA. Now, the benefits of an SoC is this tightly coupled architecture. You can program in a standard environment. The benefits of like an FPGA is a highly parallelized accelerated data path. So as we get to larger bandwidths and we get to inspecting packets all the way through, and you're getting hundreds of millions of packets per second, you need something like a highly parallelized architecture to do that. So those are the two main ones today. That early one isn't as prevalent, but some people may still have access to it. So that's a little bit about DPUs. The other thing I'd like to add is we've got a chat capability, and we will have Q&A at the end. So we'd love to see your questions come in. And as your questions come in, we will not be answering them during the chat. We'll answer them afterwards, potentially reaching out to you if we don't have time for them all. But we'd love to have our folks talk about things. So what I'd like to do now is hand this over to Baron to talk about the DPU market and where it's going.
Thank you, Ron. Yes, so let me take a few minutes to talk about our outlook on the DPU market. So again, DPU stands for Data Processing Unit, short, and is an advanced form of network adapter that interfaces between the server and the rest of the network in the data center. So basically these are like devices that are programmable, as Ron explained, and can help servers become more efficient from a utilization and a total server power consumption standpoint. The DPU market is forecast to grow from about $2 billion today to around $6 billion in 5 years, at a CAGR of around 25%. And keep in mind, this forecast doesn't include the backend network market for large GPU computing clusters, which can further expand on the market. And today, the DPU market is dominated by the top 4 US hyperscalers, mainly Amazon, Microsoft, and Google, who are building their own custom DPUs, either with internally developed silicon or with merchant silicons, and for nearly all the servers that are deployed in their own data centers. And these hyperscalers are replacing traditional network adapters with DPUs. The other market segments, such as the top 4 Chinese hyperscalers, large tier 2 clouds, and the rest of the market, such as enterprises, have also growth opportunities and generally purchase standard off-the-shelf DPU solutions. So what are some benefits DPUs could bring? So some of the hyperscalers have been using DPUs for a number of years to drive better efficiencies when operating the data centers. In the host server without DPUs, as shown on the left-hand side graphic, Some of the infrastructure overheads, such as networking, storage, and security services, reside in the host CPU. In this example, you can see that nearly half of those CPU cores are consumed by these overhead services. With the use of DPUs shown on the right-hand side of this graphic, you can see the same infrastructure-related overheads being removed or offloaded from the host CPU cores to the DPU. This frees up the cores on the host CPU so end users can run their own applications. And since DPUs are programmable devices, they can be targeted towards a wide range of use cases, such as networking and security offloads like TCP/IP and virtual firewalls, storage offloads like NVMe over fabrics, and inline data encryption. Software-defined networking is another use case that can be used to optimize network traffic and load balancing. DPUs are also beneficial for AI-based networks, reducing network congestion and allow for multi-user support. We look at DPU adoption or penetration rate by customer segments. In terms of server total available market, the US and Chinese hyperscalers account for more than half of the global server volume. In 2023, roughly half of hyperscale servers have a DPU in them, with most deployments coming from Amazon, Microsoft, and Google. Some of the other hyperscalers, like Alibaba and Oracle, are also heavy DPU users. Generally, the larger the cloud provider's infrastructure is, the more scalable and effective DPU deployment becomes. By 2028, DPUs will encompass a broader adoption among the US and Chinese hyperscalers, with almost every hyperscaler server having a DPU in them. The rest of the market, with large enterprises, smaller clouds, and telco operators, there is still a sizable market opportunity. DPU penetration rate was less than roughly 2% in 2023, and we expect that to increase to under 10% by 2028. There is potential for upsides, but requires the vendor community to work together to address some total cost of ownership challenges. Several vendor models for DPU have come aboard over time. First, there's the closed vendor model, shown in the yellow section of this table. Cloud providers like Amazon have built their own DPU and network adapter for a number of years for their own data centers. Alibaba have also been developing their own DPUs with their own processor, as the China market is trying to achieve some silicon independence. Microsoft, which acquired Fungible in late 2022, may leverage some of the IP from the acquisition for their own custom AI networks. In the other model shown below, which is in the yellow portion, this model consists of chip vendors such as Acronix, AMD, and Intel that may sell merchant DPU processors to cloud providers so they can build their own custom network adapter. In the other model, chip vendors could sell complete off-the-shelf DPU adapters to smaller cloud providers, enterprises, in the telco market that lack the resources to build their own. Finally, to wrap up my section, the DPU market isn't huge today. It's about $2 billion. But this market to expand and grow faster relative to other data center areas, such as the CPU market. New AI infrastructure could further expand on market growth. Hyperscalers can make DPUs work for them because they have the scale to drive better server utilization. The DPU market is mostly closed or captive today because of the hyperscale market, but open vendors are also making good progress. DPUs remain somewhat limited in non-hyperscale environments today, but I think there are upsides as long as vendors address key challenges related to higher costs, higher power consumption, and more software complexities compared to traditional network adapters.
Hey, Baron, thank you. And I think there's a really keen theme here, which is DPUs are primarily the area where hyperscalers are differentiating themselves. And A lot of folks in this chat maybe don't work at a hyperscaler and thinking, okay, when do I get to get my hands on them? You know, what does this technology mean to me? And so maybe let's kind of hand over to Patrick and talk about the technology of DPUs. And I see a couple chats coming in, and we're going to be addressing that as we move forward, which are where are DPUs applicable to the rest of us who maybe don't work at a hyperscaler. But Patrick, can you tell us a little bit about the structure of DPUs and technology that, you know, we look to you for an honest assessment. So can you give us one?
Yeah. So, back in 2021, I came up with this STH NIC continuum while we were all locked down in the pandemic. And, this thing has been seen by, I don't know, probably easily hundreds of thousands, maybe a few million people at this point. Very popular piece for us. I think Ron had like 4 different segments in terms of NICs. Baron has 2 for market tracking purposes, but we kind of came up with 5 because I like odd numbers primarily. But you start with a really low end NIC, and if you think about a NIC that would be, for example, in a laptop, which would be a wireless NIC, you have a NIC in a small PC like the one running the screen behind me. Those tend to be a couple dollars. They tend to be low speed, and those are what we call standard NICs. Frankly, to do 1 gig networking, 2.5 gig networking, you don't need a ton of offloads. It doesn't put that much burden on a modern CPU, and it's just less expensive, and that's kind of really cost optimized segment of the market. Moving up the stack, you have offload NICs, and that's a huge market even today, just in terms of being able to handle higher speed devices. And so you start seeing things, just even like things like doing checksumming and stuff like that are really important to offload when you get to higher speeds like 100 gig networking or what have you. The next one, which is kind of fun, is smart NICs, and smart NICs really kind of developed as that next set of capabilities, really focused on the networking side. There were some that were a little bit focused on storage as well, but that was kind of that next level functionality. But nowadays, I think folks are really looking at the next 2 over here, which kind of move out of the way so you can see them a little bit. But in terms of DPUs and what we call exotic, and I'll explain that in a second. So a DPU has a couple of properties that I think are a little bit different from a traditional NIC. And one of the big ones, I think, is just the fact that you have not just high-speed networking. So we talk about 100 gig, 200 gig, 400 gig networking, and in the future, we then talk about the fact that it has CPU cores. So we typically see a management CPU complex. The next one after that is we have memory on board, we have storage on board. They tend to run their own operating systems, and that is super important when you look at the future operating models of DPUs. The other side to that, though, is if you are running your own OS on it, you also tend to need to really focus on security. Now, that's really DPUs, and then when we talk about the exotic side, and I kind of look at DPUs, traditional DPUs, more as a SoC, and then the exotic we talk about as FPGAs. A lot of folks will say, hey, you can have a DPU implemented in FPGA, and that is 100% correct. But there are some folks, for example, some Chinese hyperscalers, and we've looked at these on the STH main site. We've done videos on them where they actually will take a FPGA, put something like a Xeon D on a card, and make a DPU solution on that. Some of the typical things that you would see in terms of architecture. You typically would see a couple models. Like one is just a sea of ARM cores to do offloading. There are folks out there doing things like having programmable P4 pipelines that you can have. You have things like other folks that are doing fully customizable things in FPGAs. There are folks looking at RISC-V versions of this. And so, from an overall perspective, there's definitely a lot going on, but you do see a couple key themes with what everybody's doing with DPUs, and hopefully that kind of gives you an idea of how these things are built.
Awesome. Thanks. Thank you very much. So we're about 20 minutes in, and we're hoping to reserve a few minutes at the end for Q&A. But I've got a couple questions that I'd like for folks to look at. And obviously, Gen AI, large language models, are hot topics today. And folks are wondering, should we expect to see DPUs in AI and ML environments, and what benefits might they bring to those? And Scott, I'd like you to take a crack at this.
Well, thanks, Ron. Good question. Yeah, we'll see DPU or DPU-like technology flow into the AI/ML space, because the objective of networking in AI/ML is to reduce latency, increase determinism between the blocks that are doing the compute work, and obviously extremely high bandwidths, right? So DPUs allow us to facilitate all of that in an FPGA environment like we have at Acronix. We have a high performance 2D network on a chip that operates at 2 gigahertz. And what that allows us to do is to define logic blocks dynamically on the chip to do the high-speed interconnect between various adapters in the chassis and connect the 2500 ML cores on each FPGA chip to the other ML cores on the other chips on the other boards. So you're going to see that type of technology. It may not necessarily be in discrete DPU slots or boards. It may be as logic blocks, but as we've seen with some recent NVIDIA announcements, they're pushing their BlueField 3 stuff right into the heart of the AI/ML space. So I think we're going to see it blend nicely across all of that.
Baron, where do you think DPUs play in this AI/ML space?
Yeah, definitely. There's been a lot of talk about DPUs using for AI/ML environments. And I see a couple of key benefits. One of it is like offloading the control plane, right, functions, such as the storage and networking functions, to the DPU for the front end network, right, of these AI-based clusters. What we call like sort of the north to south traffic, basically improving the resource utilization of these accelerated servers. Also, in the scale-out clusters of GPU compute platforms, having the DPU can also help enable multi-tenant use, right, of these systems. Ability for multiple users sharing these large training systems to improve resource management. And having this resource management shared securely and privately among users. And another advantage I see with the AI use case is to use DPUs in scale-out GPU clusters for the east to west traffic, or the back-end networks that connects essentially all these GPU servers one-to-one or in a large mesh. So typically today, InfiniBand is used for these kind of back-end networks. And as we know, InfiniBand is a proprietary network developed by NVIDIA for their own GPUs. And InfiniBand has kind of the inherent advantages, right, in terms of low latency and congestion control, as opposed to Ethernet. But DPUs, when used in the Ethernet-based kind of network, can help overcome some of these inherent limitations, especially for these scale-out clusters. So anyone who is looking for an open architecture like Ethernet-based networks and having access to multiple vendors can also consider incorporating DPUs as part of their kind of AI infrastructure.
Okay. So Patrick, well, first of all, nice sweatshirt. Love the swag. Do you work for Serve the Home? Let's see. What do you think about, like, the challenge across the technology is that there's always this advance. And what do you think about DPUs and AI/ML? Is it really applicable?
Yeah. So, a couple things. So first off, I just want to address something because I know we got some comments on it. If you want to find the 2021 STH NIC Continuum, you can just search for that. And you'll be able to see it. This chart behind me in big. So I know folks couldn't see that well. The side on the AI side, I think is really interesting, right? So we talk about AI clusters, and a lot of people today think of AI clusters in terms of training, and in that side, frankly, the NVIDIA DGX or HGX platforms are super popular on the training side. I don't think anybody's, their revenue numbers are really supporting that. And one of the things they do is they actually push the BlueField solutions into those. And then when you look at the new solutions like the NVL72 that they just announced last week, those have BlueField 3 DPUs in all of them, right? So I think from a training standpoint, I think if that is going to be bundled with NVIDIA products, and that is going to be something that they are going to push. I think that you have to kind of go beyond that, though, when we talk about AI and ML, right? The inference infrastructure, I think, is really going to be fascinating, right? That is going to be the big build out once you have models trained, being able to actually go and serve a lot of users with that. And I think that for those, DPUs, a lot of those actually use Ethernet networks because they tend to be user facing. And so for those, that can make a lot of sense. And being able to offload any compute that you're using, especially expensive CPU compute, offloading that to DPUs, I think is important. But then, kind of taking the next step, that AI inference doesn't just happen in the data center, right? That AI inference at some point needs to happen at all different parts of compute, wherever that is, whether that's a server that's in a data center, whether that's a server that's in a grocery store. I use hot dog stand. Maybe that's a little bit much for this example, but the idea of a DPU is really to secure endpoints, to offload a lot of functionality in terms of networking and storage, and building AI inference capabilities into that not only can help with the way that you manage your storage, manage your networks, manage your machines, but it can also help with just doing AI inference at the edge. And so there are folks looking at putting AI acceleration onto DPUs that can be used by the host just for extra tops. So I think that there are a number of different ways that can happen on the AI side.
Okay, thank you. So I'm going to switch just a little bit. And one of the things about being in networking for so long is I was here from 1 gig to 10 gig and 10 to 25. And, it's almost boring switching from network speeds, because the question is the capabilities that we've added from smart NICs. We added offload capabilities. DPU, we're adding compute capabilities. So Scott, I'd like you to talk a little bit about where do we expect DPUs to evolve beyond just speed? It's not about 800 gig, 1.6 terabit, or whatever. Like, what capabilities do you think, what features do you think are going to be added to DPUs to make them more effective network elements?
That's an excellent question, Ron. Thanks. What we're looking at Achronix is taking a lot of the value that the hyperscalers have gotten out of this technology and bringing that down for everybody else, right? And part of that is what Amazon and Microsoft have done with huge flow tables, and being able to put a flow table in the DPU, in our case, in an FPGA as a block of logic, and then front the flow table with a rules engine that's multi-level, so that as a packet comes in for a brand new flow, it hits the rules engine. We determine what to do with the packet based on the rules. We then update the flow table with a fast path approach for the next packet in that flow. And then we take the appropriate action. And that kind of thing, where we're taking hyperscaler technology and bringing that down to, the tier 2s and the enterprise, is where we see probably the biggest next big thing that's going to hit the DPU space.
Hey, Patrick, what when you look at it from a feature perspective, because you do a lot of, I call them teardowns, but you do a lot of breaking things down. Where do you think things are going?
Yeah, I mean, so I think that the DPU space is really interesting right now. So, I know you mentioned earlier we got some comments on, what about the rest of us non-hyperscalers, right? So we have done pieces before looking at the VMware ESXIO and NVIDIA Bluefield 2. We did not just NVIDIA, we also did the AMD Pensando DPUs with that. So, those right now, we're really focused on networking. I think storage would probably be the next logical move. And so, those tend to be the two big ones when we talk about where DPUs are today. I think in the future, we're going to have more storage-focused DPUs because that's kind of the second set of capabilities that is easy for folks to understand, easy to consume. And then, I think what's more interesting is how does a model, something like an AWS Nitro model, kind of trickle down into the kind of mass market? And I think that is going to be a key to how DPUs evolve in the future.
Okay. and maybe you addressed it because I'm a marketing guy. I still don't know the technical stuff. How do things get below the hyperscaler? Like what individual, you talked about storage, but are there, is there something that allows this to go into the SMB market or something like that?
Yeah, I think even just below the hyperscale market is probably one of the more interesting ones, and also maybe throw in some large banks and other types of financial institutions and what have you in there. One of the challenges I think a lot of folks have, and I always go back to the AWS Nitro model, is just kind of like, what are the coolest capabilities you could have, or some of the base set of capabilities you could have in a DPU. And you look at what that operating model is, it's really kind of taking the hypervisor and a lot of the kind of base level functions and moving them to the DPU. So that way you're not using CPU cores to run your hypervisor. You're not using CPU cores to run your networking, your storage. You're offloading those with dedicated accelerators, dedicated CPU cores, and really freeing up those resources, those expensive CPU resources, for other kinds of work. And so I think to move that to a kind of next step down, it's really a challenge of how do we get folks, or how do we have an operating model where DPUs can handle all three of those things? How do we get a hypervisor working on the DPU, and be able to offload those functions? How do we get the storage offloaded? How do we get the networking and secure networking offloaded? And so I think that's a very challenging problem. I think VMware was probably one of the leaders, frankly, in that space, where they've really said, okay, we're going to go and have our own software stack. We're going to run ESXi on the which is a special form of ESXi on the actual DPUs. And they started with networking. Next was, I think, storage, and then the vision is after storage, I think they're going to start thinking about doing like host provisioning and all that kind of stuff. I think that the cool thing from a VMware perspective is moving folks on the platform and kind of moving those hypervisor capabilities and responsibilities and moving those onto the DPU is a good way to onboard more folks. So I think that's an important one. I know Red Hat's been doing a lot of work with that as well. And I just kind of think that that's really being able to think of, here's what the end state operating model is, and how do we move functionality over, I think is probably one of the big ones. In the meantime, you're kind of picking off specific functions and saying, hey, we can do better offloading. But I think that to really get folks to adopt it, you have to be able to change the operating model. The challenge is that's a ton of work.
Gotcha. Yeah, definitely. So let me do a quick time check. It's about past. We'd love to hit some of these questions. And Baron, you talked a lot about the hyperscalers, and basically that 2% number is the hyperscalers' adoption of DPUs at this time. So how, maybe we can do just a quick one about how are they altering the role played by DPUs, and how, or if they are altering the role played by DPUs, and if it'll stay in that space, or if that growth to 10% is getting beyond the hyperscalers. And then we'll move into the Q&A phase after this.
Yeah, definitely. That's an interesting topic. So, I mean, the hyperscaler has been very disruptive, just not to the DPU market, but to the network adapter market in general as a whole. And particularly for DPUs in the last several years, right? As most of the large clouds have their own custom DPU deployments. And just to give you a perspective on the size of this hyperscale market, kind of the Microsoft, Amazon, Google accounted for roughly actually 60% revenue of the DPU market last year. So it's pretty significant. And as I said, rather than them buying kind of off-the-shelf adapters from chip vendors, they've been building their own and sometimes developing their own ASIC, like the case of Amazon with its Annapurna acquisition. And other times acquiring silicon, right, from merchant vendors to build their own solution. And with this, they've been able to realize really strong return on investments using their kind of high economies of scale, often shipping and deploying millions of DPUs per year, right? That's how they are going to make it work, right? And the hyperscalers has been really successful in building their own DPUs because they can achieve really a high level of integration and have access to their own internal software developers to optimize DPUs for their whole stack. Basically, all the offloads can be optimized from both networking and storage standpoint, implementing DPUs for kind of multi-tenant environments, having kind of isolation buffer between kind of bare metal servers to the rest of the network. These are really critical elements for any cloud provider operating infrastructure as a service to enterprises. So with this high level integration with hyperscalers, they also are able to cut out kind of the vendors, right, in the supply chain, which help them reduce costs, have better control of the roadmaps and supply chain. So DPUs has been really become important for these hyperscalers as they optimize both general purpose servers and storage, as well as new AI deployments.
Okay, thank you. So let's go into a few questions. And one of them we got beforehand was basically with these types of DPUs out there, the tightly coupled SoC and the FPGA, there's some questions about what use cases. And when you look at high volume packets, when you look at why would you use an FPGA versus an SoC with ARM cores. So Scott, what are some of the use cases where you would actually use a programmable element versus a CPU core based element?
There are a number of them. One of the ones we're working on now is we're working with a telco for their 6G deployment to accelerate that technology so that they can handle up to 400 gig Ethernet a few years out. And, they've got a variety of different requirements. One of them is obviously, 400G support and kind of a pipeline stage model. Another one that just recently came up was a flow through shell, which is kind of an odd thing. It's the security folks would look at it as a man in the middle type of implementation where traffic flows in one port, gets modified, and then it flows out the other port. And conversely, it flows, the other way as well, which is not the type of thing you typically do with an off-the-shelf, NIC device. And in that case, you're trying to sustain wire rate and keep the latency as low as possible, and only do the transform that you want to apply to the packets that are specifically the ones you're looking to transact against. So that's one example. Security is another big one in this space. There are a variety of different things. Like you take a look at the flow table I mentioned earlier, the rules engine that maps very well to firewall companies. We're talking to several different firewall companies in the space where you can actually implement, a firewall in the DPU that can support tens of millions of connections, right? And be able to filter off bad actors, as they show up and hit the system. They just get dropped because we know that range of IP addresses or that specific IP address is coming from a nefarious place. So there's a wide variety of things. Network analytics is another big one too.
Thank you very much. There's some interesting questions going back and forth. And what I actually love is people are answering each other's questions in the chat, which, that's the beauty of it. So Osama had a question. How can a DPU help with EVPN, VXLAN, and NAT? This is usually handled by Cisco and Juniper, but as soon as we talk about 40 gig and above, they're tapped out. So how can a DPU, and I'm going to say it either FPGA based or CPU based, help move some network functionality to handle higher speeds? And I'll punt that to Scott.
Okay, well, what you can do is you can actually create pipeline stages that deal with those pieces of traffic very specifically. NAT, for example, is a classic one to be able to do in an FPGA. It's something that you'd normally find in, a firewall or that kind of device. And same thing with VXLAN, right? What you're trying to do is offload the host CPU or the enterprise web servers or traffic servers. And it's not terribly difficult these days to whip up a pipeline stage that offers these capabilities. And there's so much memory available on the DPUs nowadays. They're measured in gigabytes. So tracking these connections and retaining state is not terribly difficult to do. So yeah, a lot of this can be moved into DPUs, and especially FPGA-based DPUs.
Okay. So another good question coming in here, and what is the future of DPUs? I'm actually going to I want to hit this one for sure, but I want to go into the future of DPUs in infrastructure developments like OpenStack, because that's pretty critical. Patrick, I think this is something you kind of touched on, and where things are going. So what is the future of DPUs in OpenStack?
Yeah, and so I'm not going to go and talk about roadmap for folks, but just kind of as a way to think about it, not just in OpenStack, but then also kind of the various other solutions that are out there. I think that, a really interesting way to think about a DPU is really kind of using that model as the DPU becomes your secure bulkhead or beachhead for really infrastructure, right? So if you have a DPU that is that is managed by the infrastructure provider, whether that's an enterprise, whether that's a hosting provider, whether that's a cloud provider, whoever it is, if you can say that is secure, and then you can provision services against that, whether that's VMs on the main server CPUs, whether that's storage being brought in from the network, whether that's secure network into the rest of the infrastructure that you have there. Handling all those functions on DPUs, I think, is super important. And then there are projects like OpenStack. And a lot of folks have their solutions, so we'll just kind of make this a little broader. But really being able to integrate those DPUs with that kind of model in mind, is a super important thing. And I think that's what really gets us a lot of adoption.
Yeah, and I think that drives that lower adoption below the hyperscalers is getting it into more kind of ubiquitous platforms.
Yep.
So great question here, because I find it interesting. And the question is, can GPUs replace DPUs as GPUs become cheaper over time? And I'm going to just opine quickly. I don't know that GPUs are becoming cheaper. I mean, we're seeing more powerful, more expensive. Obviously, with competition and with supply chains opening up, we're going to see a change there. But I also wonder, maybe Baron, you can answer this. Can DPUs start replacing GPUs? Can we look at it from both angles, Baron?
Yeah, possibly. The key is to actually, in the kind of the server architecture, is to have really specific pieces of silicon that is targeted towards certain applications, right? Basically, application-specific, processors. So you actually don't want, GPUs or DPUs do like everything. You want it to be focused in specific tasks. Specific DPUs focus in networking services, like networking and storage services, whereas GPUs more for the training, right? Whether it's AI training or inference. So the silicon is designed for these specific tasks. So you get optimal usage in terms of power efficiency. So I don't, in that regard, I don't see GPUs replacing DPUs, even if they get cheaper over time. But in the future, GPUs can evolve into other kind of use cases and form factors. Let's say if you go to the edge, you may want maybe one piece of silicon that is designed for some edge workload that can handle both some type of inferencing or networking function related task. So eventually it could converge, but maybe not in its current form.
I'd like to jump in a little bit here too. I'm going to put my computer scientist hat on for a second. I look at the problem in that sense from a data type point of view, right? If you look at data types, all the traffic that flows across the network is character based, right? You might want to think, oh, well, it's stocks data and it's video and it's all this other fancy stuff. At the end of the day, it's all integers, right? If you look at GPUs were built for floating point, right? Even if you listen to Jensen and he took it all the way down to a 4-bit floating point number, right? It's still floating point with decimals, right? And that's not the type of data that flows through a network adapter. Whereas an FPGA is really just a huge array of gates or something that emulates gates that performs on the data in bitwise fashion, right? So since it's character data and there's no decimal point and all that, it's a whole lot easier for an FPGA to grind through network data than a GPU, could easily do. And so if you take, like, for example, a Chronic Speedster 7T 1500, right? We have 750,000 gates, and we've got four 400 gig interfaces, four 400 gig Ethernet interfaces. And we can actually pull data in from all those interfaces, process the data, and then push it out pretty much at line speed. Now, the push it out is, it depends upon how you define push it out, right? Push out of the network interfaces is probably more appropriate because, PCIe Gen 5 by 16 to the host is only good for 512, right? But the point is, GPUs have their place, but it's probably not in networking data.
Okay. Let's change it up just a tiny bit, because there's a lot of talk about IoT and edge. And as we start talking about that, that's not the hyperscaler domain as well. Because obviously the message we're trying to get across here is, yes, there's a huge market for hyperscaler based DPUs or DPUs in hyperscalers, but where else is it going to go? And kind of when most people are on these webinars, they're asking the question, how does this affect me? So Patrick, are there some edge use cases where DPUs might be applicable?
Yeah, I mean, I'll tell you, we're actually rebuilding one of our hosting clusters right now, and we had a serious conversation of whether or not we should still have a firewall, or if we should use a DPU. And that may sound weird to folks, but the fact is that the DPUs are as powerful as a lot of firewalls out there these days. And when we look into the future generations, we're just talking about AI, and that's like a really great example, right? You have a lot of firewalls, or advanced firewalls, will leverage essentially AI inference, right, to go in and decide whether certain flows are good, bad, if they maybe don't necessarily know what they are, but that's one of the techniques they use. And so the idea that a next generation DPU, or actually FPGAs that have AI accelerators on them, there's a whole bunch of different architectures out there. The question is, like, is that something we should go do? I think from the other side to it, I mentioned earlier the hot dog stand, the grocery store, all that kind of stuff. You look at a grocery store these days, or a bank branch or something like that, you have infrastructure that's placed on site. And so how does a bank say, at my bank location, I have a server, that local server, I need to make sure that it's secure. Having a DPU in that chassis is a really great example of, how security can go all the way from, a secure environment can be created in these kind of edge locations. So I think from that standpoint, I think, DPUs are frankly, DPUs are certainly going to come to the edge. I think one of the challenges is that, number one, you have a bigger security surface because they're running their own operating system usually. And then the other just frankly challenge is power, right? I don't think anybody's figured out how to really do a 400 gig DPU in a 15 watt power envelope at this point. And so, so when you look at things like robotics, when you look at some of the mobile things that are happening, automotive, et cetera, power consumption is a big deal. And so how do you get some of those functionalities down into something that's, a lot lower power? I think is a pretty interesting thing to think about. But I still think we're a little ways away from there. But I think for, even just kind of small hosting clusters, I think DPUs can start making sense at this point.
Yeah, as a longtime networking person, I've dealt with the PCIe 25 watt limitation on a NIC card for so long. And one of the things GPUs have done for us is made it acceptable to have more power on a PCIe slot.
Yep.
Yes, slots could go higher. Yes, you have external dongles, but now that a lot of cards out there have 200 watts, 250 watts, et cetera, it's like, oh, I can I can do a network card at 50 watts and it doesn't feel quite so bad. So that's an interesting point, especially as a network vendor.
Well, and
I
many
was
of
going to jump in, Ron, when you did that, when you're doing your evolution thing and say, hey, that first guy, that was 15 watts, right? PCIe Gen 1 by 8. And then we went to the, PCIe, Gen 2 and 3, and went to by 16, and we went up, I should say we still kept it by 8 and it was 35. And then we went up to 75 watts for a 16 lane. And then it was like, oh, well, now we get to DPUs and it's 100. And now the DPUs are 200 plus. It's really quite exploded. Now we're looking at water cooled.
Yeah. Really interesting stuff. So there's a great question here. Just came in. Security. And it doesn't matter anymore. I mean, once upon a time, security was a firewall at the edge, and now we have security from server to server within a data center. It's an ongoing threat vector. So we have to address potential vulnerabilities integrated within a DPU, hardware side channel attacks, other forms of cyber attacks. So Scott, I know you've got a lot of security expertise. You're actually certified in this space. Is adequate attention being given to address the concerns during the design phase of these processors? Consequently, can we refer to things as secure DPUs?
That's a great question, Ron. And you're right. I have a CISSP, so I'm probably annoying when it comes to this kind of stuff. It's obviously security is at the forefront of our discussion whenever we're designing new boards, GPUs. I had a call with our board vendor Bitware yesterday, and we were reviewing two of the designs we're working on, and security came up several times during the discussion on how do we protect what would essentially be the control plane of the board from any sort of side channel attack, or even something as malicious as somebody actually gaining access to the back of the server. Could they inject a vulnerability with physical access, because that's also a consideration. This is definitely something that we keep in mind when we design these products. We look at them from if I want to use the PCI Express bus to do some DPU management, does that open up a security vulnerability? Because now I've got a way in to get flow data and extract flow data and possibly put in policies and rules, because all stuff has to be done at kind of a remote management capability. So all this stuff is definitely a serious consequence for us, or serious consideration for us as we do it, even down to the point of looking at technology from some of our partners for actually securing the chips, so people couldn't try to extract the secrets from the chip, just by measuring heat and magnetism and other electrical usage and stuff off the chip. We go to that level of depth when we're designing the chip.
Okay.
So
So Baron, I'd like to get your kind of take on this just quickly, because we have one more question and we're close to the end of our hour, but we've had a really good discussion here regarding security, and you've touched on it a couple of times. Is the market going to increase or decrease as DPUs get more security, or is it just the way things have to be? Like, you're looking at sub 10% in 5 years. Is that assume that security is offloaded to a DPU, or does it have any security related assumptions attached to that growth for the DPU market?
Yeah, definitely. From let's say a cloud provider's perspective, there's security concerns, right? As they kind of offer, the cloud servers to kind of end users, how to actually secure isolation between these different users themselves, and also between the cloud provider's network, right? So DPU can actually be sort of like a firewall, right, between these different users as well, and also with the cloud provider's own like physical machines as well, right, to the rest of the network. So I think that's one kind of benefit there from a DPU perspective. We also see some of the security vendors, right, offering virtualized security appliances, right, in terms of virtual firewalls and other network security applications. that is embedded in kind of NFV form factors for servers, as opposed to using traditional networking appliances. But that could take some time involved. We know that the security market is somewhat entrenched into physical appliances, and may take some time for users, right, to migrate and adopt virtualized network security appliances solutions.
Okay. I think you just hit on something that we don't have time to go over, but it's actually pretty interesting to me as form factors, because, you know, as we get more power, do we go to an OCP form factor and so forth? Maybe that's a subject for an entirely different webinar. So Matt asked or brought up a point here about having BMCs on board. And I think, Patrick, you're a good person to kind of address this, because that's creating a secure root of trust and execution environment. Is that, maybe I'll use the word sufficient, or is that the first step, or what do BMCs do for DPUs?
Yeah, so you know, it's actually interesting. If you pull apart some of the DPUs, they actually have ASPEED BMCs on them. For folks that don't know, ASPEED is this company that they make the vast majority of BMCs out there. BMC, baseboard management controller. One of the things that you would see that commonly in is something like a server. So if you've used a Dell and you've seen iDRAC, HPE, ILO, if you've seen a AMI Megarack or something like that, you know, solution on kind of more industry standard servers. You know, the idea of a baseboard management controller is really to kind of provide a low-level access or a low-level management function to a server, and it really kind of stemmed from the idea of how do we prevent people from having to walk up to a server in a data center, right? What has happened over time is that BMCs, and there are, by the way, many different ways that vendors, even like HPE and Dell, do very different things. But there are different ways that you can use a BMC to start creating a secure root of trust throughout a system. And when you look at a DPU, a modern DPU, you know, we went through the thing that has network interfaces, CPU, memory, onboard storage, all this kind of stuff, and it runs its own operating system. So a BMC needs to have its, you know, a secure root of trust, a DPU needs a BMC to really have that secure root of trust and also provide management capabilities.
I'll actually build on top of that a little bit. In the FPGA space, at least at Acronix, we actually, you know, have a BMC on the board along with the FPGA, and the FPGA has its own control unit built into it as well. And what we do is we, you know, do the same type of thing. You need the secure root of trust and all that, and then the FPGA actually loads an encrypted bit stream, and so the BMC and the FPGA work together to make sure that you know, it's a secure compute environment for the whole platform.
Okay. Honestly, audience, thank you very much for your questions. And thank you for answering and interacting with each other. That's pretty critical. There's a lot of knowledge out there that's not going to get served from a single point of contact on a webinar. Patrick, thank you very much for your time today.
Of course. Thank you for having me.
Baron, really appreciate the market assessment. Thank you.
Yeah, thanks for having me as well.
And Scott, I'd say thank you, but I'm going to talk to you in 5 minutes anyway, since we work together. But thank you for your time. And audience, thank you very much for attending. If you have other questions, please submit them to Acronix. You can hit us off of our website. We're open to talking, not about just how do we move our products, but where is the DPU market going? Because we think it's critical. And one of the things we didn't even touch on is essentially the NIC pipeline that exists within an FPGA, and every FPGA vendor offers these things. So it's not specific to just us. Everybody's got a NIC pipeline that you can then build off of. But I appreciate the time, Alexandra Saavedra, our back-end expert, handling this webinar. Thank you very much, everyone. Really appreciate it, and I hope people got good information out of this webinar.
Great, thank you.